molecular architecture, we are seeing concept as basic MIPS implementation. So MIPS implementation, what is the expansion of MIPS? Million instructions can be executed per second. So in this, the instruction set can be classified into three major classes. One is memory reference, and second one is arithmetic logical, and third one is branch instruction. So memory reference can be associated with the opcode name as load word and store word. Arithmetic and logical arithmetic instructions are addition, subtraction, multiplication, division, likewise. In logical representation and or not, branch instructions is branch equal and branch is not equal. So in this representation, what are the steps can be taken by the MIPS instruction execution? First of all, first we have to fetch the instruction from the memory, and then the instruction memory can send the instruction to the register. So in this, the register can read the instruction and it will be identified the which register data can be performed for the further process. So first we have to read the register value, and then we can decode the register value for the simultaneously. And next one, we can execute the operation, or we can execute the operand value in the arithmetic and logical representation and calculate the final result. After identifying the result, we have to calculate the address where we have to store the result of the data. And finally, we can add the address, and we can identify the address, and we can store the data in the particular address. And finally, we can, after identifying the data in the data memory, we can send the same data to the register to store the content in the register also. So in this MIPS instruction execution, we are having a more number of components can be utilized the representing your instruction execution. So in this first one, instruction memory. So in this, memory can store the instruction of a program and supply the instruction for the given address. So this is the main two function for the instruction memory. So next one, program counter. So it is a 32-bit register that holds the address of the instruction, and this instruction is currently fetched representation. Next one, added to increment PC. So it is used to identify the next instruction what we are executing in the CPU. The next one, register file. It is used for read and write the data in the register. The next one, ALU. So ALU is to perform the arithmetic and logical operation. So next one, signed extension bit. So signed extension bit used to extend the bit value. For example, if I'm giving the data in the CPU in the 16-bit, but the CPU cannot execute the 16-bit data, so the CPU can execute the 32-bit data. At that time, we can convert the 16-bit data to the 32-bit data. So it is can be done in the signed extension bit. The next one, data memory. So the data memory is used to read and write the control signals to the data memory. And MUX, it is used to identify and it is calculate the offset value in the register, and also we can identify the offset value in the given instruction register. So this is a basic implementation of MIPS with the control signals. So see, first of all, we can store the basic instruction address in the PC, that is program counter. This instruction can be identified, this address can be stored and it can be identified in instruction memory. So in this instruction memory, we can identify the instruction what we are executing the CPU. So from this instruction, the next one we can identify the register. So in this register, we can identify the operand value. After identifying the register data, it will be sending to the ALU. So suppose if you are having the registered value can be offset value, automatically it will be calculating the multiplex and it will be sending to the ALU operation. So after calculating arithmetic operation, the data will be sending to the data memory with the help of address. So if you identify the address, in this address we can store the data in the data memory. After storing the data in the data memory, automatically the memory write will be used to send the control to the register. So the data, the output of the register value, the output of the instruction can be stored in the data memory and also in the register. So this is a block diagram for representing your PC to data memory and PC to execution part. So in this, the PC, once the PC is loaded in the instruction memory, automatically it will be added to the next instruction. So in PC, we are having a 32-bit data. So each and every address having a 4-bit representation. So in this PC address, we can add, it is used to increment the PC count. So this is a representation, or it is a basic implementation of MIPS control signals. The next one is logic design conversions. So in this we are having a two representation. One is logic element. So in this logic element, we having a combination elements and state element. Combination element is AND gate and ALU operation and OR gate. So these are the combination elements which is used to represent the combination circuits. State element, we have in a input and output. So the input can be represented with a clock representation by using a state element. So this is a basic implementation of your MIPS. So MIPS is a million instruction per second. So the basic thing is the instruction can be fetched from the memory and the instruction sending to the register. From this register, we can take the data. After take the data from the register, it will be sending to the ALU. So the ALU performing the operation. And finally, the data will be stored in the data memory as well as in your register. So this is a basic implementation of your MIPS instruction. Thank you.